Okay, hello everyone, and welcome to our third YEA Big Physics Problem video solution. So our problem for this week is a moving particle of mass big M collides perfectly elastically with a stationary particle of mass small m less than big M, and it asks us to find the maximum possible angle theta max through which the incident particle can be deflected. All right, so basically, we have this large particle, big M, that runs into the smaller particle, small m, uh, and let's say it's moving at a speed v. So it's going to be deflected like this, and we want to find what is the largest possible angle that it can be deflected. So that would be this angle, but the angle it makes with the original path of the particle. Okay. So let's do this problem in the center of mass frame. So it's pretty easy to find the velocity of the center of mass. That's just going to be mv plus m small m, and that's 0. The velocity of the smaller particle is 0. So times 0 over m plus m. So this is m over m plus m v. Okay, so then that means the original speed of, or the original velocity of the particle of the big M particle, that's v big M, is just going to be equal to its original velocity. And since we're looking at this in the center of mass frame, we subtract the velocity of the center of mass. So minus this. And this is, of course, equal to small m over m plus m times v. Similarly, we can find the original velocity of the smaller particle in the center of mass frame. The small m, originally it's in the ground frame, it's 0. So then we subtract the cm, and this is just, of course, negative m over m plus m times v. Okay. So now, after they collide, we since we're looking at this in the center of mass frame, they have to go in be on the same these velocities after collision. Let's say they're vm prime and v small m prime. They have to be in the same line in order for conservation of momentum to be satisfied. This is, of course, only in the center of mass frame. So, and yeah. And so then we can find the this VM prime, because in the center of mass frame, when like two particles collide with each other, and we're looking at it from the center of mass frame, then after the collision, their velocity is just reversed. It's negative, and that's like a detail that you could pretty easily figure out yourself. But it's also something worth remembering. But this only applies in the center of mass frame, of course. So then Vm prime is just equal to negative Vm, and that's negative m over m plus m times v. And v small m prime is equal to negative v small m, and this is m over m plus m. Okay, but now we're trying to find the maximum angle of deflection. And so we want to find the velocity of this big particle, m, big M, after the deflection. But we have to consider this in the ground frame, not the center of mass frame, because from the original, like in the original problem, we're looking at it from the ground frame. So now we have to go back. And so let's say that this, which is the original particle's path, is given by the unit vector A, and after it they collide and it goes off in some direction, let's call the unit vector of this direction B, and then the velocity is just going to be VCM times A plus VM prime times B. And of course, this B vector is the direction that we're looking at from the center of mass frame. Because when we convert from the center of mass frame back to the ground frame, we just take the center of mass and we add the vector from like the original VCM vector, which is because that's the move of the frame we're looking at it in. So this is the velocity after it's been deflected, and we want to find the maximum such angle. Okay, so now we want to maximize the angle of deflection, and since we're looking at A is horizontal here, then that would be A, well, it would just be this angle here. So how do we maximize this angle theta? Well, we can see that when B, the angle B here mixed with the horizontal is acute, obviously that's going to be smaller than the maximum, and it's at this B when A and B are perpendicular. No, since B can't go this way, of course, because B can't go that way because in the center of mass, because this is B in the center of mass frame, and yeah, so if it were to go that way, that means its original velocity would have to be negative in the other direction. So now we know that to maximize this angle of incidence, we would have to make A and B parallel. And so we can see it would look like this. And the direction of the vector in the A vector direction, the magnitude of that side is just VCM. And this is VM prime. And we basically want to find this angle and see. So then obviously that would just mean that sine theta is equal to VM prime over VCM. And this since we look at VM prime is equal to M over M plus M times V, so that's M plus M times V over oh, sorry, this should be V big M actually. Here, I just messed up because of the big M and small m. This is common mistake. So this would in fact be small m. We're here, and over VCM, we go back and we see that it's M over M plus M times V. And here, notice that originally we had this VM prime is equal to negative M over M plus M over V, but that part doesn't really matter because B is always going to be perpendicular, because even if it's negative, B and A are still perpendicular, and we really only care about this angle. So then yeah, this stuff all cancels out, and we just get that theta is equal to arc sine of M over M. So that's the answer. Theta equals arc sine M over M. And so yeah, that's the answer. And well, that's it for this week's video solution. So thank you for listening. Bye.